Welcome everyone to Knox Game Design for October 2024. My name is Levi Smith. So this month I'm going to be talking about RPG battle damage. So a little bit of a history lesson of RPGs. It all started out with traditional like tabletop RPGs, strategy games, war games, and tabletop games that were done with pen and paper and dice rolls. That involved into computer RPGs such as Ultima, Wizardry, and Might and Magic, where a lot of the dice rolls and things like that could be calculated by computer. And then that evolved into our current like turn-based console RPGs such as Final Fantasy, Dragon Quest, Earthbound, and the Saga series, among many others. Action RPGs such as Damana, Seiken Densetsu series, Crystalist, the Tales of series, Legion of Gaia, and Ys, and also into the modern day MMOs, which two of the most popular ones are EverQuest and World of Warcraft. So my first RPGs, I started out with Final Fantasy Legend here on the left when I had my Game Boy. That was actually a part of the Saga series, which I didn't know at the time. Then I think the next RPG that I played was Dragon Warrior, also known as Dragon Quest in Japan. Played quite a bit of that. And then I remember when Final Fantasy II came out, which is Final Fantasy IV in Japan. That was like a big step in RPGs. It brought the active time battle system where it wasn't strictly turn-based. You had to be quick in making your decisions, and along with the updated graphics for the Super Nintendo is like beyond anything I ever saw with the original NES. So the one thing I never understood is like when you actually go in and you attack an enemy in an RPG, after all these years, I mean, I've been playing these games since the mid 90s or late 80s, early 90s, mid 90s. I never understood actually how the damage was calculated. The math was always hidden. Some values you just didn't know, like enemy defense and sometimes weapon attack in case of Dragon Warrior, unless you had a strategy guide. And I remember there was a strategy guide that came with Nintendo Power for Dragon Warrior, which I showed off like in a previous recording for Knox Game Design. I never knew how strength, weapon attack, and enemy defense were used to calculate battle damage. It always seemed like it was a mystery to me, just because, like, if you took your strength and added that to your attack, it was always more than usually than what was actually hit. And I knew there was an enemy defense in there that subtracted off that value, but really never understood how these values were calculated. So my goal this month was to demystify the math for this. So let's go back and look at tabletop games. I've never been a big tabletop game player, but I did kind of look into it just for this presentation to get an understanding of the history and how these computer RPGs and console-based RPGs were really based on those old tabletop RPG games. So basically, in a tabletop RPG, you have a weapon attack, and each weapon has an attack based on a dice roll or a combination of dice. And then it's interesting when I started looking into it, basically your strength is just a value added onto your attack damage. I always thought like strength was a modifier or like a multiplier or something like that, but in these tabletop RPGs, it was just a base value added to your attack. If you had ranged weapons, then it looked at your dexterity for your character. So in these tabletop RPGs, at the start of a battle, then basically you have 20-sided dice, and you roll the dice, and that you roll the dice for every character, I believe for every enemy, and that determined the attack order for the battle. Then for each round in the battle, you had one roll that determines whether you're going to hit or miss. And then you had a second roll that determines how much attack damage you're going to do to the enemy. So here's some dice examples. If you're a tabletop RPG player, then you're probably familiar with these. So the first one, which I don't think is really a dice, but a D2. So you see we got D2, D4, D6, D8, D10, D12, D20. These are some of the most common ones. I don't know if there's really a D2, but basically D, I think, just stands for dice, and the number after is the number of sides. So a D2 would just be a coin, like a quarter. So you could have heads be 1 and tails 2, or heads maybe 0 and tails 1, or tails 0, heads 1, something like that. But you only have 2 outcomes with the coin. You flip it, and it should be pretty much exactly, roughly the same probability of getting heads or tails. A D4 looks like a triangle pyramid. So you have outcomes 1, 2, 3, 4. D6 is just like a regular die that you would see in Monopoly, 6-sided die that you'd see like at a casino. We're all probably familiar with a D6. D8 is kind of like 2 square pyramids on top of each other. So you have 8 outcomes with it. D10 is kind of like a 5-sided pyramid, 2 5-sided pyramids together. D12, you have 12 outcomes, and it's just a bunch of pentagrams connected together. And then D20 is a whole bunch of triangle faces together. So those are some examples that you would see in a tabletop RPG. So one thing that I found interesting is if you have a 12-sided dice, it isn't the same probability that you'll get the same values if you have 2 6-sided dice. You would probably naturally think it would be, because if you have 1 12-sided dice or 2 6-sided dice, the maximum value you can roll on either of those is a 12. But the probability of the outcomes are completely different. So I kind of went in and figured these out. So on a 1 12-sided dice, you have an 8.33% chance of getting any number 1 through 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. They're all equal. So I graphed this out on the red line, and you can see it's just a flat horizontal line. Each number outcome is exactly the same. But if you roll 2 6-sided dice, then you'll never be able to roll a 1. The lowest you can roll, like in Monopoly, is a 2, and there's a 2.78% probability that you'll get a 2, and then there's also a 2.78% probability that you'll get a 12, 2 6s. So that's basically 1 over 36, because there's 36 outcomes. You got 2 dice. Each dice has a 1 over 6 probability of landing on a value. So if you have 2, you multiply those together. So 1 over 6 times 1 over 6 equals 1 over 36, which is 2.78. So I graphed out the 2d6 on the green. So it's kind of like a straight incline up. You start at 0 for 1, then 2, 3, 4, 5, 6. You got a straight linear line up to 7. 7 is the most likely outcome you'll get on 2 6-sided dice. Then it kind of goes back down 8, 9, 10, 11, 12 and probability after that. So if you have 3 4-sided dice, which again the maximum you can roll is a 12, and there'll be like a 1 over 4 times 1 over 4 times 1 over 4% chance of getting 12, which is 1.56. So I graphed out all the probabilities. So the lowest you can roll on 3 4-sided dice is a 3. You can't roll lower than a 3. So I graphed out that on the blue line here, and you can see it's more of a kind of like a parabola, more of a curve, sine type curve, going up, starting at 3, 4, 5, and you kind of max out at 7 and 8 right here with an 18.75% chance, and then it falls off after that. And then the final combination I looked at is 6 2-sided coins. So we'll consider heads to be a 1, tail a 2. So the lowest that you could flip is a 6, and the highest you can flip it. So that would be all heads, and then the highest you could flip is a 12, which would be all tails. So each of those cases would be 1.79%. So I graphed that out, and you can see like you start here at 6, and it goes really way up high. So the most common combination you would get would be a 9, and then it drops off significantly after that with 6 coins sided 1 and 2. So that's kind of interesting, looking at how they did it with tabletop games. Well, how did they do it with NES games. I really looked into that this month, looked at some of the code, found some really good guides out there on calculating this. So first game that I looked at was Dragon Warrior, also known as Dragon Quest in Japan. I kind of tested this out with Dragon Quest, the original. I'm not sure if there's many differences aside from the language, but I think all of the damage calculations and all the weapon values should be the same between the Japanese release and the American release. So basically you have a player attack value, which is basically your strength, your flat out strength of your character, plus your weapon attack, the attack value of your weapon. And in the game, they don't ever show you your weapon attack, but you can find it online. So then there's a range of damage you can do. So the minimum damage you can do is that player attack value minus enemy defense divided by 2, and all that divided by 4. The maximum damage you can do is your player attack minus enemy defense divided by 2, and all that divided by 2. So here's an example that I did actually in the game. So I purchased a club and I looked it up online, and it has a value of attack value of 4, and my character at the time had a strength value of 5, so you add 5 plus 4 equals 9. So I kind of use this color scheme right here where strength is green, your weapon attack is blue, and your total attack is red. So you have a total attack of 9. So the maximum damage you can do is 9 minus, and we're fighting a slime here, so I looked it up online. The slime has a defense of 3, so I'm going to have the defense value in purple. So 9 minus 3 divided by 2, all over 2. That's 9 minus 1.5 divided by 2, 7.5 divided by 2. All that equals 3. I think actually it rounds down when it's doing the division. I'll talk about that in a little bit. So when I went into the game and played it, I confirmed that I was doing 3 points of damage. That says slime need 3.2 no damage ata eta. So I did 3 points of damage. There is some variance. So here's another example I looked at. So I went ahead and bought the copper sword. It has an attack value of 10. The strength of my character at the time, I think it looks like I was level 5. I had a strength of 12. So you do 12 plus 10, that equals 22. So my character's attack value is 22. The character I was fighting here was the Ghost. Looked up Gusto online, found the defense value was 8. So the minimum damage I could do is 22 minus 8 divided by 2, all that divided by 4. That equals 4.5. Again, I think the calculations are rounded down. When it's calculating this, it doesn't actually do decimal places. The maximum damage is 22 minus 8 divided by 2, all that divided by 2, and that equals 9. So I should be getting damage values from 4.5 to 9. So when I played into the game, Gusto need 6, did 6 points of damage. So 6 lies between 4.5 and 9. So the math actually did check out using this formula right here. Yes, I want to go back and show this guide. It's Dragon Warrior NES Formulas version 1.0. I'll have this linked in the notes. This guide did a lot of work in actually digging out the values online. But you can see here, hero attack formula. So this is kind of like where I found hero attack. He calls it enemy agility, enemy defense, hero attack minus enemy agility divided by 2 divided by 4, or enemy hero attack minus enemy agility divided by 2 divided by 2. But in this guide, this person actually went in and he actually looked, and I kind of did too, looked at all the opcodes in the game. I didn't get down to this level, but he actually looks at the actual math in the 6502 opcodes that's used to calculate all these. So this guy did a lot of work. If you want to really get into it and look and see how all these values are calculated, I recommend this guide right here. It's the Dragon Warrior NES Formulas version 1.0. And it is written back in 2011, but it's still a really good guide. So yeah, I kind of looked with my FCE UX emulator just to figure out like where all these values are stored. So you got your level, strength, HP, MP, max HP, max MP, golden experience. So I went in and did my memory location finder and found when these values changed, put in a known value, and when the value changed, so I was able to map like the level to memory location 00C7, strength to C8, HP to C8, MP to C6, max HP to C5, max MP to CB, gold to BC, and experience to BA. So you probably saw in those attack formulas that there's a lot of division by 4 and division by 2. And this is something else I guess I sort of knew, but I never really thought about it. But there's no division operator in 6502 assembly, which is what all NES games are written in. So how do you divide by 2? Well, if you do a logical shift right, then that is essentially the same as dividing by 2, rounding down. You're basically just shifting all the bits to the right by 1, putting a 0 at the first bit. So if you do that twice, then you're dividing by 4, and if you do it 3 times, then you're dividing by 8, and that's what I'm showing right here. There's also a rotate right, where you actually take the bit 0 and rotate it all the way back into bit 7, which you may see that sometimes. And there's also a carry flag, so when you divide by 2, it'll like put whether there's a remainder or not in that carry flag in that register, or in that register value. So I looked at Dragon Quest, figured that out. Well, what about Final Fantasy? So Final Fantasy is different, but it also has a base attack value, just like Dragon Warrior. That's your weapon attack. It's not a flat out like Dragon Warrior. It's weapon attack plus strength divided by 2. So every 2 points of strength gives you 1 attack damage, which I never, maybe I heard that in the past, but I never really thought about it. Your minimum damage is your base attack minus enemy defense. So that's easy to calculate. Your maximum damage is your base attacks times 2 minus enemy damage. So if you want to divide by 2, you rotate to the right, all the bits to the right. If you want to multiply by 2, then you can rotate them to the left, or just add that value to itself. I don't know exactly what it does, but so actually when you go into Final Fantasy, original Final Fantasy from the NES, or a regular Famicom, Final Fantasy 1, actually on the stat screen, it will show you your base attack value as damage, and that's what's circled in red right here. Your strength is right here, 20, circled in green. So if I have no weapon equipped starting out, and I have a strength of 20, then my base attack will be 20 divided by 2 plus 0, which equals 10. But if I equip a small knife, which has an attack of 5, then that's 20 divided, for the base attack is 20 divided by 2 plus 5. So that's 10 plus 5 equals 15. And there's also guides out there for explaining how that's calculated. So here's some examples I actually ran in Final Fantasy. So with no weapons for my fighter here, he has 20 strength. Just looking at the lowest enemy that I could find, the imp, around the starting area, it has a defense of 4. So the base attack, so I have no weapon, so that's 0 plus 20 divided by 2 is 10. That's what I said on the previous slide. So the minimum damage would be 10 minus the enemy defense, which is 4, so that would be 6. The maximum damage, it would be 20, which is my base attack times 2 minus 4, that equals 16. So actually when I went into the game and started attacking with no weapons, I got a 6, 6, 9, 9, 15, 8, 14, 10, 16, 9, and 9, which all lie between the values of 6 and 16. So that math actually checked out. So I equipped a small knife on, I think, one of my characters, and just did it for one character at the time. So I had a strength of 20. The imp has a defense of 4. So my base attack would be 5 for the weapon, plus 20, the strength, divided by 2. That would be 5 plus 10 equals 15. So the minimum damage would be 15 minus the enemy defense, which is 4. So that would be 11 for the minimum damage. The maximum damage would be 15, the attack, times 2. So that'd be 30. 30 minus the enemy defense, which is 4, which is 26. So when I went into the game, started attacking with that weapon, then I got damage values of 16, 23, 13, 13, 17, 17, which all lie between 11 and 26. So that math actually checked out as well. Here's one more example. So I equipped the rapier, which has an attack of 9. At the time, I had a strength of 21. I was fighting the guard imp, which has a defense of 6. So the base attack value would be 9 for the weapon plus 21, which is the strength, divided by 2. So all that equals 19. So the minimum damage would be 19 minus the enemy defense, which is 6. That equals 13. Maximum damage is 19 times 2, which is 38, minus 6, which is 32. So when I actually attacked the enemy with that weapon, then I got 32, 14, 16, and 20, which all lie between 13 and 32. So the math actually checked out for that as well. So what about my first Super Nintendo RPG, Final Fantasy IV? This is a little bit more complicated. So the base attack in Final Fantasy IV is your weapon attack value plus strength divided by 4 plus level divided by 4. So look at it. I have Cecil here. He has an attack strength of 13. He has weapon, has an attack of 10. The Dark Sword has an attack of 10. And he has a level of 10. He starts out at level 10. So his attack value is 10 plus 13 divided by 4 plus 10 divided by 4. So each of those round down. 13 divided by 4 is 3. 10 divided by 4 is 2. So 10 plus 3 plus 2 equals 15. So he has an attack value of 15. But I noticed, like, when I was hitting an enemy, I wasn't hitting them for like 15 damage or 15 minus the defense. So I was like, oh, what's going on here? I'm hitting the enemy for like 30 or whatever. So I looked at it, looked at some guys, and actually there's an attack multiplier. And that's actually shown on the character stat screen. That's what I have circled on in magenta. So Cecil here starting out has an attack multiplier of 2. So the attack multiplier is your strength divided by 8 plus agility divided by 16 plus 1. So for Cecil here, his attack multiplier is 13 divided by 8, which rounding down equals 1. 10 divided by 16 is 0 rounded down plus 1, which equals 2. So his attack multiplier is 2. So that makes a little bit more sense. So your minimum damage is your base attack, which is your base attack times your attack multiplier minus the enemy defense. The maximum damage is your base attack times the attack multiplier times 1.5 minus the enemy defense. We look at Kane over here. So he has a strength of 9, weapon attack of 9. His spear has an attack of 9, level 10. So his base attack value is 9 plus 9 over 4, which is 2, plus 10 over 4, which is also 2. So 9 plus 2 equals 13. So his attack value, base attack value is 13. His attack multiplier is 9 over 8, which is 1. 11 over 16 is 0, rounded down, plus 1. So his attack multiplier is also 2. So you take that 13 and multiply it by 2. So here's an example here also with the Goblin in Final Fantasy IV, also known as the Imp. So Cecil, his minimum damage is 15 times 2, and the enemy defense is 0. So 15 times 2 minus 0 is 30. His maximum damage is 15 times 2 times 1.5 minus 0, which is 45. So when I actually tested it out, I was getting actual attack values of 36, 38, 32, 42, 40, 42, 34, 44, and 42, which all lie between 30 and 45. So the math actually checked out. For Kane, his minimum damage is 13 times 2 minus 0, which is 26. His maximum damage is 13 times 2 times 1.5 minus 0, which is 39. So his attack values when I played the game were 36, 30, 30, 26, 32, 28, 34, 28, 20, 38, and 36. which all lie between 26 and 39. So the math checked out there as well. So that's basically it for RPG damage. Just an overview. I wanted to thank the guys at Cody Lambert at Dev Mood. I did a talk there last week, last Friday. Had a good time doing that. Enjoyed everybody, enjoyed the time there speaking to the blockchain and NFT talk for game development. So I appreciate everyone there, and also appreciate everyone here listening and watching, and I plan on being back in a month. Thanks.